In this lesson, we'll be taking a look at indexing or data. So what is indexing? Indexing, like sorting, is a means or mechanism for reordering or organizing the data in our table. Unlike sorting, however, indexing does not physically rearrange the records in our table. They may appear to be physically rearranged, but in actual fact, they're not. With sorting, the records are physically reordered, thus resulting in another table being created, which results, of course, in the duplication of data. So you want to keep your sorting to a minimum and your indexing to a maximum. Now, for information's sake, Visual FoxPro supports three types of indexing. There is our index files. There is a structural compound index, which is the standard index, and the one that we'll be looking at today. There's a non-structural compound index, which is similar to the structural compound index, and I'll explain the difference when we get back to that. And then, of course, the standalone index, which is from the old D-base, Fox-based days, and it's still here in FoxPro VFP 9 for backward compatibility, and it's also used when we would like to create temporary indexes for one-off sorting. And I can't think of any examples right now, but bear that in mind when you work with standalone index. You would want to do that for temporary indexing only, and I'll get back to that later. Okay, structural compound index. A structural compound index is actually a file that is created when we do create an index, and it must have or will have the same name as our table name. The table that it's associated with will actually be the name of the index. The extension, of course, will be different. The extension, in fact, will be CDX. The compound just simply let us know that within this index file, we can create multiple index names, or more commonly known as tags, index tags, and I'll demonstrate that as well. The non-structural compound index is similar to the structural compound index, with the exception of the name. The name for your non-structural index is not the same name as the DBF name. The non-structural compound index does not have to be stored in the same folder as the associated DBF name, and likewise, it can store multiple tags. And of course, the standalone, unlike the compound, can only store a single index, and it creates a single index file on your hard drive. And actually, I will take a look of an example creating a standalone index in this lesson. So let's go ahead right now and create an index for our My Table 1. So we've got first and last name here, James Cameron, Andy Bloom, Polychronis, George. I'm going to create two indexes, or rather two tags, one for the first name, one for the last name. And to do that, we use the index command. We say index on, and we must specify now an expression, or more commonly an index key. So in our example, our index expression or index key will be first name. So what I'm telling the Visual FoxPro to do, rather, is to look at the fname column in My Table 1 and compare all the values in there, sort them, and when you create your file, put them in the proper order. So we will specify fname. I'll just put this in lowercase just to differentiate, and then I use the keyword tag, and that will differentiate and let Visual FoxPro know that I wish to create a compound index. So tag, and in most cases, at least I do. The tag name, I give it the same name of my expression if it's a single, if the expression is based on a single column and not multiple columns. So in this example, the expression key is fname, and the name of the tag is also fname. Just to help minimize confusion for now, until you're more comfortable with this, I'm going to put a 1 in this just so you know. So the 1 is for the tag name, and I'll go ahead, press enter key. Visual FoxPro tells me 5 records were indexed. So what happens when we index is, again, Visual FoxPro look at all the values and creates a file with all these values in there in the order that I want them. And the default order, of course, is ascending order. And so physically here we had James being record 1, Andy record 2, Mary record 3, George record 4, and so forth. In the index file, physically, Andy will be record number 1. Who will be the next guy? David would physically be record number 2. Again, this is just in the index file, not in the physical, not in the associated DBF file, only in the index file, which is a much smaller file. These data items are physically placed in the proper order, and pointers are in that file, which points to the associated DBF to show us the records in order. Now, when I click on the browse window here to refresh the screen, we will see the new order in effect. I have not clicked on it yet, so we're seeing the old order. And something to point out here: once you create an index on a table, the last index created becomes the effective index. So I'm going to go ahead and click on the browse window here, and now we're seeing that our data is reordered according to the index. Now again, the records in my table 1 are not physically reordered, right? The the information in the index file, however, are physically ordered according to the column. I hope I've not emphasized that too much. Okay, so just to prove that to you, my record pointer right now is on Andy, which of course we're seeing displayed as the first record. But then if I check the record pointer down here, it tells me that physically Andy is the second record in the table. And let's see what David is. David is the last record in the table, the 5th record. George is the 4th, James the 1st, and Mary the 3rd record. So the indexing does that for us, and a great tool that it is. Now let's go to Explorer and see what FoxPro did when we created the index. So here, without actually specifying a name, Visual FoxPro created the compound index file for me. Notice the extension is CDX. However, the name of the file is as the associated DBF. mytable1.dbf. When you create a compound index for it, it will create a mytable1.cdx by default. Now, the bonus, or the great thing about the structural compound index, and why we want to use it all the time, most of the time, is that when I open my table, the index, the compound index file, is automatically open for me, so that when I make changes to the data, those changes are automatically propagated to the index file, and I don't need to have to manually force a re-index on my table, so that things are now in sync. So if I make changes here, it's no problem. In fact, I'm going to just go ahead and close this. And just before I do that, I want to point out that once an index is active, in your data session window for the selected alias, you'll see my table 1 alias. There's a little arrow to the left. It shows that an index is active on this table. So I'll go ahead and close. We'll go back here, and we'll see the index file. Okay, so we'll go back to FoxPro. I'm going to reopen this table. Use table 1, and we'll browse. We see that the data physically has not been changed the records have not physically been reordered. They're physically the same. What I'm going to do to illustrate that the index is automatically open and any change I make to the data is automatically propagated to the index is just to go ahead and change Andy to Mandy. Actually, no. Let's change that to Randy. Okay. Okay, so what will happen is now when I'm going to turn on, and let's go back to the data session window. There's no arrow here, so I know the index is not active. So when I turn the index back on by saying set, to turn an index on, we use the set order command, set order to, and of course we can just specify the name. I get IntelliSense here telling me what the name of the tag is. I only have one tag in my compound index, and it's displayed here. If I had several of them, all of them would be listed here by IntelliSense for me to choose. And it is telling me that the name of the tag is fname1, and the tag or the index expression is the fname column. So I could just simply select that and press enter key. So it says master index, and it now tells me that I have the fname active. I go back to the data session window. I see the arrow there. I click on the browse window, and right away my records are reordered. Notice that Andy, who previously was at the top when we first created the index, once I change the name or modify the name in some way, it's automatically updated. I did not have to recreate the index. I did not have to issue the reindex command, as we would have in olden days when working with the standalone index, or if you were working with the non-structural index, you would need to reindex the data once you open those index. Okay, so let's go ahead and create one more index, and we'll do that on last name. So we'll go index on lname tag lname1 and press enter key. And now it tells me that I must use table exclusively. And so when you're indexing, tables must be used exclusively. So, and that's just to ensure that there are no changes being made to the data while you're creating the index. So I'll use this again, and I'll just put exclusive at the end. And then I'll go back up to this line and press enter. And now if I browse, I should see everything in order by last name. Now I can also and will create an index that is based on last name and then first name. Okay, so we'll go index, and this is how we create a compound expression, index on, and we specify column 1, and then we use a plus sign to join the next column, fname, and then tag. For this one I'll say full name, as that is the full name. And press enter key. And now this becomes the active index, and we should not see much of any change here. Okay, so I want to set the order back to last name, so I'll set order to lname. And now that I have three tags within my index file, IntelliSense is showing me all of them, and along with the key expression used to create each tag. So we've got fname, full name, and lname, and you can choose any one, but only one index can be active per table at any given time. So I select last name here. The status bar shows that the controlling index right now, or the master index, is lname1. Now, what are some of the benefits of indexing? For one, as I mentioned earlier, we don't have data redundancy. We don't have duplication of data. I still have my table 1, and now I can do neat things such as searching, which is exceptionally fast with indexing. I could tell Visual FoxPro to seek, and I specify the key value, and because because our master key is based on the last name column, I'll specify one of the values, the key values in here, and I'll specify Parker for this example. Note that it must be in the same case as on which the index was created. So I'll say seek Parker, and this should move our record pointer from record pointer. Right now it's on record 2 to wherever Parker is. Now, just bear in mind that when an index is active, the record pointer does not necessarily display represents the same order as the table are listed. So, okay, I seek, and that happens to be record 5, though it's being displayed here in the browse window in the 4th position. So that's what indexing gives you. It gives you the ability to search for key values within your table. And likewise, I can seek for any of the values here. Cameron. Note I put quotes around the value that I'm searching for, and it jumps there. I do use the find command, and I use it exclusively in the command window. I never use it in code, as it's a bit problematic. But with find, I can leave out the quotes, and I usually use this when I'm lazy. I don't wish to type the quotes, and I could say find Bloom, and I don't need to put any quotes there. It works just like the seek, and notice the record pointer jumps to Bloom. One of the things also that you can do, and this is a little bit advanced, but we'll come back to this later. We can use the browse command. I can say browse, and because I have an index, I can specify the key clause, and I could put P. Now, Visual FoxPro will perform an inexact match and should show me everybody whose last name begins with the letter P. Let's see if that is true. And here we go. So using the browse key, again, this is based on the index, and because of an inexact matching, we get everybody who begins with P. Okay, so we're just going to go browse normal again, and we have the table. Now, what I want to do is to, just for backward compatibility's sake, is to create a standalone index for demonstration purposes. Okay, so what we'll do, we'll create a standalone index based on the, we'll use the last name as well. So to do that, we use the same index command, index on, lname, but we use the to clause, and we specify now the name of a physical file. This is not a tag, it's the name of a physical file that will be created on our hard drive. So I'm going to call this lname1, and press enter key, and Visual FoxPro is telling me that I already have one existing, and I'll say no. In fact, that just told me that I'm not in my C lesson 1 folder. So I'll just copy this and set default to C lesson 1, and then go ahead and issue this command again. I mean, it's the same result. It's the same lname, but if we go back here, we'll notice something different. Visual FoxPro now creates, according to the name I specified, lname1, and by default the extension is .idx for, that's a single index or standalone index file. And you get the same benefits as a compound in terms of the ordering and the searching ability. However, of course, if you were to create multiple indexes, then you will end up with multiple files. Also, if I were to close, let's say I close a table and I open it again, note that this index is not automatically opens. Standalone indexes are not automatically open. Compound indexes are. So when I make, if I make any change to the name, let's change Bloom to Doom. And also, I'm going to add a new record to the table. During spawned, somewhere. So I've changed a name and I've added a new record. My compound index will have been updated because it's automatically open with the my table 1. So this is not a problem. If I were to go and say set order to LName, notice the set order to always reads from my compound index. Not a problem. Bond is moved into its proper place along with Doom, and everybody is visible. Okay, let's set to turn off an index. We can set order to, and we don't specify anything, and our table should resort to its default or physical order. To turn on the standalone index that we've created here, LName1, to open that, we use the set index to command. Set index to LName1, which now is a physical file. Let's see the result of not having this open when we made a change to Bloom's name. Bloom was now Doom. So Bloom is shown, Doom is now shown as, the first record from the point of view of the browse window. But notice that Bond is missing. Bond should have floated to the top had the index been open. So basically, the LName index is still operating on the old information that it had, where Bloom was the first record, which is why Doom is still here, and it has no knowledge of the Bond record that we created, and therefore it doesn't show it. It's actually filtered out. So to update this, I would have to be sure that I use a table exclusively. I would set the index to LName1, and then I would issue the reindex command, and then that should fix 6 records are indexed, and then now Bond, Cameron, Doom, and everybody is displayed accordingly. So that's just a brief overview of indexing. We looked at the compound index, standalone index. We look at using the seek command. We looked briefly at creating a compound expression using full last name plus first name. I did not do a seek. To seek on this, it would be the same. I would specify last name, then followed by a first name. And there's a little caveat here, because we would need to take into account the spaces that are after the name. But we'll look at that in another lesson. So in a nutshell, that's it for indexing.